Hello, everyone. Thanks for having me. My name is Sohan Maheshwar. I've worked in the industry 15 plus years. Spent a long time at AWS and startups. Now I'm at Authorized. Fun fact, I might have traveled the most to get to this conference because I live in the Netherlands. And Humble invited me to speak here, so I was like, yes, because I'm originally from Bangalore. So it's always nice to come home and speak to the Bangalore community. So thanks for having me. OK, question for you. Does anyone remember this product from Google? And if you know the answer, you might be an old person like me. Yeah, few of you all? Yeah? Do you know what it is? Yes? Do you know the name of this product? It came a little after Orkut, yeah. Does anyone remember the name? So this was a social network that Google started sometime back. What's that? Yeah, Plus, Google Plus. So the answer is Google Plus. And the idea was, instead of having everyone see all of your pictures and photos and videos, you could have people in different circles. So you could have like college friends and work friends and family, and you could share things with each of them. Right? Now, as a social network, it didn't really do well. We don't use it anymore. But why it is kind of relevant is how Google did their authorization sort of changed once they started building out Google+. In fact, if anyone here has sent a Google Docs link in an email like this, you might have seen this pop up. Right? So you have an email, you send a Google Docs link, and it says, hey, does this person have access to that documentation? Now, this actually is magic, if you think about it, because Gmail is one app, Google Docs is another app, but there is a centralized authorization that's actually happening. And how this happens is through Google's internal authorization called Zanzibar. And we know exactly how Zanzibar works because they actually released a white paper in 2019 describing all of it. Right? And I'm here to talk to you a little bit about how Zanzibar works. Now, for those of you all who have used Kubernetes or even at work, traditionally authorization was done in something called RBAC, or role-based access control, where you're assigned a role like software engineer. And all software engineers can check in code. A salesperson will have a role saying sales, and they can check quarterly reports. Things changed a little to something called attribute-based access control, where everyone has an attribute. So I have an attribute like name, email ID, location, age. And when a decision had to be made, you check all the attributes, and you say yes or no. Now, the two methods have its own problems, and Google, being Google, they have planet-level scale. So they had to rethink how that was done. And essentially, in this paper that they call Google Zanzibar, they popularized something called relationship-based access control. And I'll tell you what that is. I highly recommend everyone reads this paper. It's written in very simple, readable English. You'll find it on zanzibar.tech. And they describe how their entire internal authorization system works. It's very impressive because in 2019, they could handle more than 10 million client queries per second. So, of course, they have scale. And the first word in the paper is consistent. It says Zanzibar, Google's consistent global authorization system. And for those of you all here who have worked in distributed systems, you'll know that having something global and consistent is very, very challenging. And that's what the paper describes. So let's talk a little bit about that. And let's talk specifically about RBAC. Now, RBAC is like the cool new kid on the block. Suddenly, everyone's like, oh, this relationship-based access control is very interesting, because instead of having roles or instead of having attributes, everything is a relationship from one thing to another. So say you have a document called Steal the Moon, and it's in a folder called Evil Plans. The relationship between the two is this document exists in this folder. Similarly, you have users or persons, and the relationship between the folder and the person is that the person is a viewer. The relationship to another person could be editor or commenter. So you have different things, and you have relationships between different things. What are those things? Well, in Zanzibar, one thing is a user. So if you have a Google ID, you have something called a Gaia ID, and then anything else, any object like a document, a video, a photo, Google Maps link, anything is an object. And that way, you can draw relations between a user and an object. So again, because you all have used Google, you all will have in your Google account relations between the documents, the YouTube videos, and so on. And some examples are you can be a member of a group or an uploader of a video, and so on. So you have users and objects, and you have relations between them. How do you represent these? Well, the Zanzibar paper describes these things as relation tuples. So how to read this is start at the hashtag and start at what's to the right of it. So user number 3 is an owner of document 123. And this way is very flexible in how you would actually draw relations with anything, because you can also have objects relate to other objects and objects relate to other objects' relations. So for instance, the group security is a member of the group engineering. So in your company, say there's a reorganization. Suddenly you're like, oh, security used to be in product, now security is going to engineering. In role-based access control, that would be super hard to reassign everyone. But here, it's just a matter of having a new relation tuple, which changes the relation, and then your internal authorization changes. So what are we doing with all this information? The idea is, and if you've studied some computer science theory, is you build out a graph with all of these relations. Right? So here's an example. It's a directed acyclic graph, or a DAG. I'm going to use the example of Google Docs again, because we've probably all used it. You have a document. You have a reader, Fred and Kim. You have a writer, Jill. Now, these are the relations. You will see an arrow from reader to writer, which means that all the people who can write to a document can, of course, also read to a document. And this gives you flexibility, because you can add a new parameter to it. You can say, hey, I want to add an organization. So you just add something to the graph. You say organization called Acme, and there is something called an admin, and everyone who's an admin is a reader. And we know that everyone who's is a writer, and we know everyone who's a writer is a reader. So you can build out these directed acyclic graphs for your different permissions. To find out if someone has permission, right? We want to check if Jill here is a reader of this document. All the system does is check if there's one unidirectional path from document to Jill. In this case, there is, right? We can go from some document to reader, to writer, to Jill, and hence, Jill has permission to read the document. Same way, we have to check if Kim has write permissions to the document, but there's no one direction between document, writer, and Kim, so Kim does not have permissions to write to the document. So this is internally how Google is actually checking for permissions when you access anything via your Google ID. And the question I get asked is, okay, all that is good, but how does this actually scale? And that is a whole talk in itself, because that is the very cool parts, but there are two things that happens. One is every request is broken down into sub-problems. So for instance, if you go back here, the check starts with some document, reader. No, Jill is not here. And then it goes to writer, it checks for Jill, and it says yes. So each of these are classified into sub-problems, which are then cached in different instances of Google Zanzibar. So the next time someone asks about Fred, you've already solved this, right? So it doesn't go back to the graph and ask that question, because you've already solved that problem. So there's very aggressive breaking down of these problems into sub-problems, and then aggressively caching as much as possible to access this data faster. Because remember, this authorization is on the critical path. Anytime you open a document, it has to go through this to check if that person has permissions or not. So you have to have very high availability and low latency, because of which there's a lot of caching, and there's also batching of reads to the data store. So say you get like 50 requests all at once. The first request is made, and then the other 49 will use the cached version. So you're batching requests that way. Now, the thing is, when this came out in 2019, there was a lot of buzz in the security and IAM community, because everyone's like, whoa, this is very interesting. So big companies started implementing their own versions of this. Airbnb, Carta, they all, even now, use their versions of Zanzibar that they have written internally. At the same time, they've also open source projects based on Zanzibar. Now, how many of you all know that Kubernetes was originally a Google product? It was used internally at Google, started off called Borg, then they documented it in their white papers, and then people built the open source version so that other people like us can use it. So similarly, there are 4, I'd say, popular versions of the Zanzibar implementation that are open source right now. There's SpiceDB, Ori, OpenFGA, and Permify. They're all open source. They're all based on the Google Zanzibar paper, so you can use them to build permissions into your product. I'm going to use SpiceDB in my demo today. SpiceDB was originally authored by the leadership at Authorize, but it's grown into like a large project with contributions from Reddit and GitHub and Netflix and so on. It's completely open source, so feel free to check. And the only metric that matters to us as developers is, anyone, what is it? It's of course GitHub stars. So there are 5,700 GitHub stars on this. But again, completely open source, so feel free to jump into the community. I'll tell you how SpiceDB works, and it aims to stay as close to the Zanzibar paper as possible, right? So essentially, SpiceDB is a highly parallel graph database. The name DB is there in the name, but it's not a general purpose database. So you cannot use it as an RDBMS. You have to use it as a database for authorization queries. It's written in Go with gRPC and HTTP APIs. And like the Zanzibar paper, there are 3 main things that you need to know about. The first one that the Zanzibar paper says is, how do you model any use case that you have? Like you have Google Docs or you have YouTube. How do you model that into an internal authorization system? And they call something called schema, right? So going back to Google Docs, you have a user as a writer of a document. A writer can read and edit a doc. Simple problem statement. So you can model this in something called a schema by defining the users and the objects. So you're defining a user, you're defining the object, a document, and you're defining the relation between the user and the object. In this case, a user can be a writer or a reader of a document. And you define the permissions for each relation. So you say, and a writer can edit a document and read a document, whereas a reader can only view the document. Also, you can create, read, update, and delete relationships. I showed you that graph earlier. So you can do that using SpiceDB or any Google Zanzibar implementation. For instance, if you want to add something like, OK, Fred is a reader of this document, Jill is a writer, you write a relationship tuple that I showed you earlier. You just say, hey, we have this document named some document, and user Jill is a writer of this document. So you're reading, writing, and updating relationships into based on your permissions. And lastly, you check for permissions. You want to check if, hey, does someone have access to this or not? There are 3 ways you can do it. Going back to our old graph here, one is you want to look up or check for permissions, like say, does Kim have reader permissions? It'll return a yes or a no. There are a couple of other cool things you can do. You can look up subjects, which is basically saying, hey, give me all the readers for some document, right? So it traverses the graph, and it goes, OK, Fred, Kim, Jill, Niv, all of them can read this document. And you can also look up resources, which is a reverse lookup. So you can actually go and say, hey, give me all the documents that Fred has reader access to. And then it traverses the graph the other way, right? And here it comes to some document, but maybe there's document XYZ at the bottom as well. Now, remember this because we're going into the AI part now, because Zanzibar actually thrives and shines when you have lots of data, when you have relationships between data, when you have low latency, and when you have hierarchical permission models. And guess what? In RAG pipelines, which I'll talk about now, all of these things actually matter. So having a Zanzibar-like system that uses relationship-based access control really makes sense when you're using a RAG pipeline. So let's get into it. this is what we're all here to listen about, AI. We all know people are using AI in prod. If 2024 was the year of people trying out AI, I feel this year is the year that people are actually trying out AI in production. We have RAG pipelines, LLMs, agents, apps, MCPs. So today I'm specifically talking about RAG pipelines. And if you're not familiar, it stands for Retrieval-Augmented Generation. And it is an architectural approach, right? Let me be very clear. It is an architectural approach where you have a corpus of documents and data, and instead of training a model only on that, you actually augment an existing model with information from your documents. So training a model specifically on your documents is too expensive, but asking a general purpose model about some domain-specific data will cause hallucinations. So you have a regular model, and you augment that with information from your documents. And that's what a RAG pipeline is. Now, a few of y'all might be familiar with this community called OWASP. Has anyone heard of it? Yeah, right? I think if you've committed code to any production system, you've heard of OWASP. It stands for Open Worldwide Application Security Project. And they come up with security risks for web apps, for LLMs, and so on. So they came up with a list last year about security risks for LLMs, and 3 of them stood out. Disclosing sensitive information when information comes out that it's not supposed to. When you give an AI agent excessive agency to do things it's not supposed to. And also embedding and vector weakness, where I embed like some malicious code into like a vector database, which can cause problems. And these 3 stood out because these 3 can be solved with proper authorization. And that's the demo I will be showing you today. Typically, this is what a RAG pipeline looks like, where you have a knowledge base of documents. There are 2 phases. The first one is the ingestion phase, where you have some pre-processing, like breaking down and cleaning up the document, which goes into an embedding model. For those of you all not familiar, embedding is a way to represent words in numbers, right? So the vector representation of king and queen will be very close, but king and raincoat won't be very close. And that's how computers can understand words and context. So you get that in the embedding model, and you store all of that in a vector database. And this is when your ingestion of data happens. And now a user can query the same thing. So the query also goes through the embedded model, which goes through the vector database. And then your query and your prompt is sent to an LLM, which sends a response back. And I have a feeling most of us are using some form of this, whether you know it or not. The thing here is, my system's going, yeah, there we go. The thing here is, I don't know why my, there is no security anywhere or no authorization anywhere here. And that's what I'm going to talk about, which is securing RAG pipelines with fine-grained authorization. Fine-grained basically means you can specify documents and have very, very fine ways of giving authorization. Something like role-based access control is called coarse-grained, where you have a role which is very wide and it's not fine-grained enough. Okay, so there are 2 techniques. I don't know. There are 2 techniques by which you can actually do fine-grained authorization on your RAG pipeline. The first one's called post-filtering, where you filter afterwards. Right? So this is what it looks like. You have a query which goes through an embedded model, and your embedded query goes through your vector database, and you get the relevant context. And then you put it through an authorization system. So when it returns all the relevant embeddings, you check the permissions for each of these with a Zanzibar-like system. So remember earlier I said you can do a check permission request. So you check permissions for each of these, and only the things that the user is authorized to, you can send a response to the LLM. So only the things that the user is authorized to goes to the LLM. Thus, the RAG pipeline is giving you access, or giving the user access to only the documents they are authorized to. And then, of course, you get a response. Now, this post-filter method actually works well when you have a high positive hit rate. So say you have like 1,000 documents, and you have a high positive hit rate, then it makes sense to actually, run this through a post-filter method. Let's look at a pre-filter authorization approach where you make a query which goes to the embedding model, and here you do a pre-filtration as to what resources the user can actually access. So right here, instead of doing a check permission, sorry folks, my mouse is not working for some reason. Technical difficulties always happens. There we go. Oh. Yeah, there we go. So, coming back to it, you write to your embedding model, and you first ask the authorization system what resources can the user access. And you get a response, and then you can actually go back to your vector database. So this is called a pre-filtration approach. Right? So when you have a low positive hit rate, you can actually do this because out of, say, 1 million documents, maybe you have access to 10, and then you can go to your vector database and then hit the LLM. So in today's demo, we are going to actually look at this pre-filter approach where we will use Pinecone as our vector database. I'm sure you would have heard of Pinecone. It's a pretty popular product out there. We will use OpenAI as our LLM. Again, I'm sure we have all used OpenAI. And we'll use SpiceDB, again, open source for our Zanzibar-like system. And to create the embedding model, we will use LangChain, again, a very industry standard framework for now. The demo I'm going to create is actually pretty straightforward. So what we're going to do is we'll have two applications, and the application will have some data in it. And we will ask a query to the LLM based on that data in that application. And then we'll remove permissions to that document, and we'll ask that same question again, and we'll see what the response is. So the demo is all available here in a workshop format, so you can follow it later if you want. Feel free to take a photo as well. And for this demo to work, you just need a Pinecone account, OpenAI account, and API key, and you can have a SpiceDB instance and a Jupyter notebook running locally. So very low touch, simple demo. Let's see how that works, okay? All right. I hope you can see this at the back. But essentially, remember I told you about schema? Well, I'm defining my schema here, where I say I have a user, and I have an article. This is my user and my object. The relation between the user and object is a user is a viewer of an article, and all viewers can view the article. Super simple, nothing crazy. And I have an instance of SpiceDB running locally over here. It's just the binary running on my local machine. We will see any updates that will jump here. So what I'm going to do first is write the relationships in this data. I have two documents. Document 1 is an article with object ID 123. So I will say my user Tim is a viewer of this document. And we have an object ID 456, and Tim is a viewer of this. And we are going to write this relationship to SpiceDB. So I'm just going to run that cell. And you will see in SpiceDB at time 12:18, there is a write relationship call to my local instance of SpiceDB. Right? So it's instantly writing to this authorization database. We'll double check and we'll say that, hey, actually before that, I've created a Pinecone index here. I've already created. If you open Pinecone here, you can see the Pinecone index here. And it uses the Pinecone serverless model. And what I'm going to do is I'm going to create something fictitious in the document, right? So in document 123, I've added this line of text saying, Bill Gates won the 2025 Oscar for Best Football Movie. Now, first of all, there's no such Oscar for Best Football Movie. And if there was, I don't think Bill Gates would win it. So we've just added some joke text in that document. But in reality, this could be something like your quarterly reports or some HR information or whatever. I've initialized a LangChain embedding object to create my embedding. And I've upserted that data into my Pinecone database. So the document data has been upserted into my Pinecone database. I'm just going to double check using a lookup resources to see what articles user Tim can access, right? Let's see what it says. So it says Tim is authorized to view article 1, 2, 3, and 4, 5, 6. You will see a lookup resources call made to the database right here. Now, here's the fun part. So we have gone through this part of the pre-filtration, like all of this. So now we'll actually call to the OpenAI and see what happens. So I'm creating a LangChain object for an OpenAI chat model. And I'm just going to insert all of that into my Pinecone index. And then I'm initializing a retriever here with a context which is only from the authorized articles. So I'm saying as part of my RAG pipelines, this is authorized to view. So get context from there. And I'm initializing a string prompt template, simple prompt engineering, to ask the question, who won the Oscar for best football movie? Again, this information is only in that one document, because we know it doesn't exist. So let's run it. And it's running it right now. And hopefully, there we go. So it's used our RAG pipeline to look at that document and saying, yes, Bill Gates won this Oscar. Now, you will see that it's, there was a lookup resources here. So our RAG pipelines worked. But what if access to our documents changes? So we'll remove Tim's authorization to access this document. So here, I'm deleting a relationship between user Tim and object 1, 2, 3, where this information is. So I'm going to delete it. You'll see that call has been made here, a new write relationship. And let's check what articles Tim can view now. So Tim can view only 4, 5, 6 document, which there's absolutely nothing in. And let's ask that question again to our LLM. Right? So we have asked this question. It's going to the LLM now. And it says there's no information provided because there's no access to that one document where the answer to this question was. So it's not hallucinated it either. Yeah? So essentially, we have looked up what resources Tim can access. If he's able to access that document where that piece of information was, you get the information back. If he's not, then it says, sorry, I do not know. Of course, you can change the output to also be like, sorry, that information you're not allowed to authorize to access, and so on. Now, this is a cool approach, and of course, this is a simple demo, but you'd be surprised to know that in production, AI companies are using this approach right now. It's just that all of this will be in, highly optimized for scale and availability and consistency and so on. But this is the sort of architecture that they're using because Zanzibar-like systems were meant to be deployed at large scale, at low latency, at high availability, right? And if it works at Google scale, then it should probably be good enough for the rest of us. There is a second order effect of these things, which is because you are checking only documents that you're authorized to, you actually end up optimizing your RAG pipelines. Now, in this demo, there were 2 documents, so there's no question of optimization. But in the real life, you'll have like 1 million documents. So running through some access control and seeing who actually has access to what helps you optimize these RAG pipelines so that you can work at lower latencies as well. At the same time, you get audit logging to see who can access what, because these things change often. People ask me, hey, why can't I use something like an OpenSearch to filter? But OpenSearch is optimized for search. You want to use something optimized for authorization, right? And that's the idea. And of course, this leads to efficient RAG pipelines at scale. For next steps, this whole thing about Zanzibar is fairly new, so I would check out the Zanzibar white paper. It's 12 pages. It's online on zanzibar.tech, so just read it on the weekend. This demo is, again, available here in a very step-by-step format, so you can check it out. And you can check out SpiceDB or join the Discord or YouTube or documentation, whatever you want, basically. And I'm around for a bit if you have any questions, but I just, again, want to say thanks for having me. Totally worth coming all the way from the Netherlands to speak to you all, so thank you.
Any questions, guys? All right. Okay. Thank you, Sohan, for your wonderful insight on rack pipeline. Here's a token of gift from us. Thank you. Moving on to the next. Yes. Please join me in welcoming Ms. Preeti Venkatesh, AI Solution Manager at Intel Corporation. She will be speaking on the topic Kubernetes-powered AI, scaling enterprise workload with OpenAI. We are honored to have her here. Please, Johnson. Yeah, you can. I mean, we have the LAN cable. Also, don't forget to hashtag us. It's KCD BLR25. And also you can tag us KCD Bangalore.